Hi everyone, I'm Nicole from Primary Engineer and welcome to our online engineer interview today, who is featuring Julie Canning, who is a Senior RF Design and Optimisation Engineer at Network Rail. So this one is to do with introducing a girl to engineering day. So we're hoping to inspire you to get involved. Before we get started, I'll quickly run through what's going to happen during the session. So the first part of the event will be Julie's presentation, which will be followed by a Q&A section. So please feel free to type in any of your questions at any point during the session, and hopefully when we get to the Q&A, we can get through as many as possible. Participants should use the Q&A facility, which is accessible at the bottom of the screen, to type in any questions that you might have. So if you're an engineer, what would you do? The competition main aim is to inspire young people ages 3 to 19 to look at the world around them and design solutions to problems. This can be something as simple as making toast or getting dressed to a worldwide problem like pollution or plastic waste. We provide opportunities for you to meet and interview engineering professionals online, just like we're doing today with Julie, to inspire you to think of some ideas and start designing some inventions. To help you with this, we have lots of available resources posted on our website. So after our interview today, make sure to go and register for those and check them out. So without further ado, I'll pass over to Julie.
Good morning. My name's Julie Canning. My job title is a Senior RF Design and Optimisation Engineer. Now, though I work on the railways, I actually deal with the mobile phone network that's on the railways. So a bit like the phone networks that you've got on your telephones, your mobile phones. So I actually live in Newbury in Berkshire. Normally I would work at Paddington Station, but obviously with what's happening at the moment, I'm working from home and I can do everything I need to from home. I've been at Network Rail a long time. Used to work for Vodafone, so that's where I'd learned my mobile communications. Hobbies like running, cycling, swimming, that sort of thing, and it's quite nice to get out every day with a bit of exercise at the moment. Why did I become an engineer? Well, at secondary school, my school teachers thought I would make a good engineer. I think this was probably because I was always going, what's this, what's that, asking questions about things, and I was quite good at maths as well, and probably a bit creative. But I didn't really agree with them at the time that I should be an engineer. So I ended up leaving school with A-levels. When I first left school, I was a library assistant. Then because Vodafone has their headquarters in Newbury, I worked in customer care. I had a really good manager that was encouraged women to get into engineering. So I'd actually moved into the engineering department at Vodafone. So I was a technical clerk, which meant just doing paperwork and stuff. But again, it was technical paperwork. And so I did day release with Vodafone because they were very good at encouraging their staff to do that sort of thing. And I ended up helping out with designing the 2G network for Vodafone. I also did a bit of work on the 3G network, but obviously we've moved on a lot since then. You've got 5G in that now as well. So I did a degree with Vodafone. So I did a joint honours degree in business management and telecoms. The reason I did that was so that I got a greater depth of knowledge with the technical side, but I also had some business knowledge as well. When I left Vodafone, I took a job at Network Rail and I'm still there now. So doing a similar job that's changed bits and pieces over the years. So what I actually do, I've got a small team, and in the team, we actually have to decide where to put mobile phone masts along the railway lines to provide coverage to the train drivers. And it's actually called GSMR. So it's the same technology as the 2G that's used on your phones, but a slightly different frequency. So we would look at fixing problems on the network. So if there was a coverage hole, so like with your normal phone, you know that sometimes you can't actually use it in certain places. Well, on a railway, obviously you can't have a coverage hole because then the drivers can't contact anyone. So we have to work out why there's a problem and fix it. There's lots of different things to do. We get involved in lots of different projects. We're presently involved in HS2, which I expect you've heard of. So we're doing work for HS2. With technology changing, in the future, there's a possibility that you won't actually need the signals along the railway line. So you know the red and amber signals you see in places, they may be taken away because it will be able to use the telecommunications system to manage the trains. So we also look at future technology a bit. And the other side of that is you never know, in the future, you might not need a driver for a train and it'll be all automated. So this is why this slide is to represent why you need what we call, so a mobile phone in a train is called a cab radio because it's fixed all the time. So it's so that the train driver can contact the signaller. So I've got a nice picture of a train driver I met in Scotland a long time ago. And these are a couple of pictures that show you a landslide by a tunnel. And obviously the train sat coming out the tunnel, so it had to be stopped. And then you have to stop the trains coming in the opposite direction so there's not an accident. So the driver can press a red button on the telephone to do that. And again, the bottom picture is a train. It looks like it got derailed. It's gone into a gantry. So they would have had to ring for help when that happened. And they would have to stop all the other trains in the area, which is what they would do with the phone. Now, this is how the mobile phone looks on a train, because it's actually fixed. It's not like one you're carrying around. The red button is for emergencies. So what would happen is that, so if that train was coming out the tunnel and saw the landslide, then you would press the red button and that would stop all the trains in the area. So it doesn't message the network, and it would make certain that all the trains would stop so that they didn't run into the landslide. The yellow button, you can contact the signaller. So you might find you're stuck at a red signal on the train. So you know when your train suddenly stops and you don't know what's happening. Well, the driver doesn't know what's happening either, so he'd have to use the phone to find out. So he can contact the signallers and ask how long he's going to be sat there for. This is a couple of pictures of different masts on the network. You get lattice ones, you get poles. A lot of the commercial operators like Vodafone would maybe hide a mast and just actually make it look like a tree. So you'll find that some masts look like trees and they can be painted. Ours, unfortunately, look like this a little bit most of the time. We've got over 2,500 of these masts around the country. So when you're going around next door, going for a walk, you can look out for masts, and if it's on the railway line, it might be one of ours. If it's elsewhere, then it might be Vodafone or O2 or one of the other commercial operators. So these cab radios are installed in all the trains. Here's another picture. So this gives you the cab radio and the handset. As you can see, it's been labelled GSMR. The picture on the right, your mobile, so this is the mast and a normal mobile phone. Even when you're not using your phone, it's monitoring, it's listening to the coverage from the network. So it's listening to the signal to see what's happening, making certain you've got enough coverage on your phone. When you make a call, then it's called dedicated mode. And that means that your phone actually talks to the network. So you'll have the mast and it'll be like a two-way conversation. So this is an example of how you would design the coverage along the railway line. So this line, the line underneath the bubbles is the railway line. And each of the different coloured bubbles sort of represents how much coverage comes from that mast. The little arrows that I've put on there, they indicate sort of orientation you want to provide the coverage up and down the line, because we don't care about covering the villages next door, because as a the only person that can use the coverage is the train driver, so you wouldn't use it on your normal mobile phone. And this is just a picture of the antennas on the site, so you can actually keep an eye out for these and have a look and see what they look like, and you'll find smaller ones, bigger ones, and it'll depend on the frequencies being used by the operator. So this picture, a few years ago when we were first designing the network, you had to make certain it worked properly. So Network Rail's got yellow test trains that go around the country, and they record the data from the network. So they record the mobile phone coverage, but not only that, you'll find they'll record information about the tracks. I believe they've got cameras on them so they can look at the tracks and look for faults. So as well as telecoms engineers, you'll have engineers that look after that side of the railways and would analyse that data. If we've got a problem on a network in a certain area, then we can get hold of this data, and then we can analyse it, have a look at it, and see why there's a problem, and then fix it. And this picture, the picture in the middle, is of a group of us on the test train a long time ago when we were first setting up the equipment, but now it's automated. So you'll find that somebody will go onto the train, there'll be like a train manager, he'll just start the equipment working, and at the end of it, the data gets uploaded like on Wi-Fi to the network, and then we can use it. This is just a plot of, we have to use a planning tool to predict the coverage. So the little triangles would be the orientations of the antennas, and they would then, as you can see, we can predict it. So you put the height of the mast in there, the orientation, and you can actually down tilt the antennas. And if you down tilt something, it sort of provides coverage closer to the area. And you can see, so like the red is a really, really good signal, orange is good. So the areas that are white are where we don't have any coverage, and where it's the blue colours, that's a lot lower coverage. So that's where, when sometimes your mobile phone doesn't work very well, it's because it's in an area where there's not very good coverage. And that's the same as with us, with the mobile network or network rail. The other thing with that is it doesn't matter for us. We don't need to cover the houses and stuff. We only need to cover the train tracks and the train stations. So where it's white on this map, that's actually going to be okay because it won't be train stations. Okay, that's all the sites combined. This map, you can see all the different colours for the different footprints of the cells. So you can see how far they cover and what direction they are. So that makes it a little bit easier to see. Now this plot is actually a plot of the terrain of an area. So it shows you where the hills and the valleys are. So where the pink is and the brighter orange is the high bits of ground, and the white and the yellows and greens are the lower ground. And as you can see, I've got some sites on there for the railway, so that's where the railway line goes. The best way of describing it with masts is that if you're higher up, you're going to cover further because you can see more. So if you stand on a hill, you can see a long way, so the radio waves will go a long way. If you're in a valley, it's a bit like lights. If you turn a light on, it can't see around the corner. You can't, and that's the same as radio waves. They can't actually see around corners. So that's why it's quite difficult to get coverage sometimes. So this is, I'll give you a picture to show you this. So this is what we would call a cut-in. So this is up in Scotland somewhere. And if you were on a train going through there, it would be quite difficult to provide coverage. So your normal mobile phone may not have coverage in this area because it's difficult to provide it into it. But you'll find that on Network Rail, our mobile phone in the cab will have coverage because we'll have designed it to make certain it's covered. And the picture on the right is just another different mast with different technologies on it. So I think that's our antennas at the top, and the lower antenna, we're testing different equipment to see how it works. So if you were a mobile telecoms engineer, what do you think you would do? How would you improve how your phone works? What would you want to use it for? Do you want to use it to play games? Do you want to use it to talk to your friends? And what do you think the future is of mobile phones? It's sort of, that's where the creative side comes into it, because you can get involved in the development side of it and seeing what happens next. And that's it. Thank you very much.
Thank you for that, Julie. That was really interesting. I never realised that the masts were painted to look like trees.
Yeah,
that's
I was going to
say.
you can Google it, and there's some quite good pictures of them. So you'll see something that looks, sometimes they look like odd trees. You'll get a really funny shaped tree and you think, well, that doesn't look right. And if you look closer, they've got antennas on them.
Yeah. I've never realised that. To be fair, I've never looked. So
No,
maybe when the people watching go for a walk, they can try and spot them.
Yes, yeah.
So you mentioned just then the creative aspects of engineering. Do you think that you have to be a creative person to be an engineer?
I think it helps. I think if you're someone that likes asking questions and is coming up with new ideas, so it might be that you might want to, like we just said about hiding the mast, you might want to think of a creative way of actually having mobile phone coverage in an area, but customers not knowing, so that it doesn't spoil how pretty areas are. Yeah. So you can use that side of it. And being creative, you can think about other ways of getting coverage into places and things like that.
Do you think that's the most difficult part of your job, is trying to figure out how to get all of that coverage along the lines?
Well, we've probably got a slightly easier bit because we decide where we want to put them, and we give a map to someone and say, can you go and look for somewhere along this bit of railway line? And of course they come back, and it's them that have the hard job. They have to look to see if there's enough space for it as well. So they have to look for space, they have to look to see if we've got any transmission as well. And it can be difficult. So sometimes they come back and it's not quite where you want it. So then you have to look at, can we make it work? So for us, you could change things like the height of the mast. So you could do smaller masts at 5 meters if it's only a small hole, but you might, our maximum mast were 29 meters, but most are about 15. So you'd look at, actually, I wanted to put 10 meters in there so that it didn't spoil the view, but we're going to have to go slightly higher, otherwise we can't solve the problem. So
it's finding that balance then, I suppose.
It is, yeah. Yeah, it is.
And so when you were entering engineering, I know, did you do a degree, and what kind of subjects did you do during your degree?
Well, when I first got involved in engineering, I didn't have a degree. I did it working for Vodafone. They put me through like a sponsorship. I think a lot of the companies now do, they've got graduate schemes, but I think they're all also going back to apprenticeships quite a lot. So with those, they're quite good because you can learn on the job. And I know at Network Rail, the graduates, when they come in, they actually move around lots of different departments, and then they don't have to decide straight away what they want to do. For me, I did a degree in telecommunications and business. And that was so that I got more of the technical information. So though I could do the job because I knew how to use the tools and things, I didn't know why it worked and stuff like that. So by doing the degree, you just get a better depth of knowledge with it.
And when you started in Vodafone, did you see how many women, let's say, were in Vodafone compared to now in 2021?
When I started there, I worked purely with women because it wasn't engineering. And then when I moved into engineering, you would find that the female staff would tend to do the more admin jobs. But I was very lucky with Vodafone because they encouraged the women to actually move on. So though you might start as an admin person or doing technical clerk work, if they thought you had the aptitude to move on, they were very good at encouraging you. So I never really had a problem with that. So though you ended up working mostly with men, it was never actually a problem. And I think even now at Network Rail, there's a lot of men at Network Rail because of the industry it is. And I forget there's not many women. So sometimes even now I'll go to a meeting and there's 20 people and you're the only female there, which is okay. When you've done it, you don't think about it, if that makes sense. And I've always had no problem with it.
I was going to ask you, have you been blocked at all as a female in engineering?
I don't believe so. No, I think it's always been okay. I think it's always been very positive. And I think if you're not careful, they've probably been nicer to me, trying to encourage me more than some of the men. So kind of positive discrimination in some ways. But yeah, and I know when I was at Vodafone, they did go through a phase where they were trying to encourage more women into technical jobs. There's no reason why you can't do the technical jobs. And even at Network Rail, you've got people trackside now that are women, which is great. My job at the moment, most of it is at home. There were stages when I would go out on site and stuff. That was never a problem.
Yeah, that's good then, isn't it? So what do you think about if you're an engineer, what would you do competition? Do you think that it's really beneficial for students to start participating, to get involved in engineering?
Yeah, I think it's great. I think it's a great idea. It's something that, well, when I was young, I dismissed it. I wouldn't have been an engineer, but my teachers thought I should be. And then I slowly ended up going in that direction anyway. So I think they should definitely look at it, especially if you like learning things in the sense that, fixing problems, analysing stuff, that sort of thing. Yeah, it would definitely be worth looking at.
You mentioned it as well at the beginning that in school you were quite creative and you were good at maths. And do you think that to be an engineer you have to be good at those? Do you think you have to have that creative personality?
I think it helps, but even with my maths, I had to really work at it. So I wasn't somebody that was naturally clever at maths. So I don't think you have to have it. And when you actually do the job, I think it's the same as a lot of jobs. You've learnt the background, but you don't actually use it that much in the role. Now, some engineering jobs, you can use lots and lots of technical stuff. But in mine, we use a planning tool that does a lot of the work for you. But it's good knowing how it all works.
Mm-hmm. And also, a lot of people, use a lot of different programs in your career. Do you think there's a program that you wish that you'd learned earlier so that you're kind of ahead of the game almost?
I suppose for me, I am at Network Rail and it's quite old technology. We're learning new things and new developments. So like ETCS is to do with removing signalling and making certain you can use the trains that way. But I've not worked on things like 4G and 5G, which is the new technology. So I like the way I've gone, but if you're more ambitious or if you want to learn more, you can go along those routes. There's a lot of information about antennas and technology. There's lots of different areas you can go to depending on what you're interested in.
And what do you think are the pros and cons of engineering?
Ooh. I think it's the sort of thing that there's always something changing. So if you can't get bored. So I've done a similar job for a long time, but actually the role's changed over the years because you've done things differently. So I think that makes it quite a positive thing, is that it does change and it's not the same all the time. Cons? I don't know, really.
No. Well, that's a good thing. If there's no cons.
Yeah, no, it's been absolutely fine. Yeah.
So we do have a question. Did you enjoy building or creating things as a child?
Yes, yeah. I think I was a lot into the crafts. I had loads of Lego, that sort of thing. So I was always building Lego and had a box of Lego at home. And I think crafts, anything you could make, I was probably making at that stage. And I like painting as well. So I enjoy doing art. So I think art's quite appropriate because you can use that for being creative, can't you, as well?
Mm-hmm. And have you always been, part of or enjoyed trains? Because you are in a very train focused career.
Yeah, but no, I wasn't a train person.
No, okay.
Even now, though we work with we're designing a network for the trains, we don't actually have to interact that much, if that makes sense. Mm-hmm. So we obviously have to know how they work and how it all fits together, but it wasn't something I was sort of really desperate to work with.
So you lead a team of engineers. Do you think that you have to have? Do you think you need to be collaborative in your job?
Yes, yeah, definitely. I've got I've just got four people working for me, two ladies and two men, so we're quite well balanced in my team. And you'll find that if you're doing, especially at home now, if you're doing a task, quite often you'll just ring one of your colleagues to actually talk it through with them. So with the work we do, there's probably more than one solution quite often. So you might ring someone up to say, well, I'm thinking about doing something this way. Is there enough, and you'll then work out the best way to solve a problem. So yeah, it's quite good.
Mm-hmm. Do you think it's a positive, like, do you think it's beneficial that you've got such an equal distribution in your team? Two women, two men, you've got two different outlooks,
Yeah, I think it definitely helps. I've got a lady that's originally from Thailand and a lady from Venezuela as well, and somebody from Central America. So that also adds to the mix, and they've got different cultures that it brings to the team, and that seems to work really well. Yeah.
It seems like a really interesting, diverse team.
Yeah.
So do you think there's a part of engineering that you would, like to explore in the future? Do you see any kind of change in what you're doing?
It's going to be interesting as to what happens with what's called ETCS and removing the signals and things like that. That's going to be quite a challenge because it can be quite difficult with some of the problems we get. So that's going to be interesting. We're also looking at, with data, we only use what's called circuit switch data at the moment, but we're going to be using packet switched in the future. Now, the commercial operators have used that for years. So it's quite old technology, but it's still going to be quite interesting to learn more about it and how it all fits together.
So there should be quite a few new kind of roles that maybe people that are watching today could get involved in.
Yeah, and also GSMR, at some point, it will be replaced by something called FRMCS, which is Future Railway Mobile Communication System. But at the moment, that's still being decided on what it actually means. So there will be so once GSMR is done, at some point it will all change to new technology. And there's also work going on with the commercial operators, things like that. So that it does change all the time. There are sort of different areas you can get into.
So you've worked on a lot of projects, from 2G all the way to like a rail projects. Do you think that was beneficial in your career to have such a diverse portfolio, let's say?
Yes, it's helped. Yeah, it's good to have an insight into how the other technologies work, even if we're not always using them at the moment, because you don't know when you might need them in the future or where things might change. So yeah.
And what's the next step? Oh, what's your favourite part of your job?
Ooh. Well, because I'm managing a team, I actually quite like managing the team as well. So as well as the technical side, you've got looking after the people and making certain they're okay, and obviously do one-to-ones. We have team meetings at the moment because it's a bit more difficult. We have coffee chats or coffee mornings, have half an hour where we all catch up on Teams and things like that. I enjoy doing that. I'm quite lucky that my team are doing set pieces of work at the moment that's coming. So to try and help them out because they're busy, I do the ad hoc work that comes in, and that makes that quite interesting. So it's sometimes dealing with the problems to stop them going to my team, if that makes sense.
Mm-hmm. Yeah, a diverse day.
Yeah, so it can be quite variable.
So we're running out of time a little bit. So do you think that you've got any advice for any of the young and budding engineers that are watching today?
If it's what they want to do, find out a bit more about it and talk to a few people about it, and also look at the different ways you can get into it. So don't just assume that the degree is the best way. Have a look at, see if there's any apprenticeships. And I think that applies to a lot of engineering jobs at the moment. So I think when I was younger, you had a lot of apprenticeships, but now it's gone towards more, and then it went to just having the degrees, didn't it, I think? But I think it's going back to apprenticeships, so it's learning on the job. I think learning on the job's a really good thing, and it doesn't mean you can't do a degree part-time if you have the right support from the company, really.
So there's quite a lot of entries to engineering, really.
Yeah, I think so. So, and some people, you know, at 18, you don't want to carry on in education. You think, well, I'd rather go and work. Well, you can get an apprenticeship where you learn a skill, and then you might find after a couple of years, like I did, actually I want to do a bit more education, and it works quite well that way.
Yeah.
So.
Well, thank you everyone for watching, and thank you, Julie, for taking time out of your day for joining us.
No problem.
Hopefully you've been inspired for this Introduce a Girl to Engineering Day special of the interviews. So if you feel inspired to take on the challenge and design a solution, then you can head to the leadersaward.com website for more information. So thank you everyone, and we'll end it there. Thank you, Julie.
Thank you. Thanks a lot. Bye-bye.